to complete their octet, the atoms, they either share electrons which is called covalent bonding, or another type of bonding is they give or take electrons, and this is called ionic bonding. There is yet another type of bonding, that is coordinate bonding, but we'll be discussing that later. Now let's take the example of sodium. This is the electronic configuration, and let's take the example of chlorine. This is the electronic configuration, right? Now sodium, if it loses this electron and gives it to chlorine, sodium will convert into Na plus ion, that is 2,8, and its outermost shell, that is the L shell, this is the K shell and this is the L shell. Its L shell will be, in this octet, will be complete. And chlorine, after having received one electron, will convert into a negative ion, and its octet will also be complete. This is in the M shell. This is the K shell, this is the L shell, and this is the M shell. So in the M shell, which is the outermost shell, its octet will be complete. Now Na plus and Cl minus, they are held together by an electrostatic force of attraction due to the formation of ions. So this is the formation of ionic bond. Another name for ionic bond is electrovalent bond. So if sodium gives one electron, then the electrovalency of sodium, electrovalency is 1. Same ways, chlorine accepts one electron, so its electrovalency is also 1. You can either say sodium electrovalency is plus 1 or chlorine electrovalency is minus 1. Now, some of the characteristics of ionic bond and how will we represent it. Number 1, compounds are generally solid. That is, the ionic compounds are generally solid. Secondly, high melting and boiling point. The reason is, supposing we have Na plus and Cl minus, it's very difficult to break this force of attraction and segregate the ions so that it can melt. So they have very high melting point, and if they happen to be liquids, in case they are liquids, they have a very high boiling point. Thirdly, very good conductors of electricity due to presence of ions, because ions are the carriers of electric current. Fourthly, very good conductors of heat. This is so because due to the electrostatic force of attraction, the solids, they are in solid state. I just explain it to you. Now look at this. For example, Na plus is there and Cl minus is there. They held together with a very strong electrostatic force of attraction. So they tend to be very good solids, and the density is very high. And because the density is very high, obviously They are good conductors of heat. Because the more dense a material is, the better it is a conductor of heat. So they generally occur in solid state and very good conductors of heat due to high density. Then you have, I think this is the fifth point, dissolve soluble and polar compounds. Now these ionic compounds themselves soluble in nature and like dissolves like. Polar solvents, sorry. Soluble in polar solvents. For example, water, it is a polar solvent. And you have Na plus Cl minus, this is an ionic compound which is itself polar in nature. And how are they soluble? Na plus is pulled by OH minus ion, and Cl minus is pulled by H plus ion. As a result, they separate from each other. Okay, so they are soluble in polar solvents. Sixth is non-directional in nature. How are they non-directional? Just try to understand this. Let's see, we have a crystal lattice of Na plus Cl minus. You have millions of Na plus surrounded by millions of Cl minus. Every Cl minus is attracted by Na plus and every Na plus is attracted by Cl minus. You have this entire lattice. Now let me take one Na plus here. If you look at it, it is attracted by Cl minus on this side and it is attracted by Cl minus on the left hand side. And because attraction is equal and opposite, the net attraction on it is 0. Same ways, it is attracted by Cl minus on top and it is attracted by Cl minus at the bottom also. So net attraction is again 0. So Na plus is not net. If we say that Na plus has a particular orientation, it does not have any orientation or direction, because it is attracted by Cl minus on all sides and with equal magnitude and which is opposite. So as such, there is no particular direction of Na plus in which it will be oriented. Same ways, if we look at Cl minus here, it is attracted by Na plus on the right hand side, it is attracted by Na plus on the left hand side. So net attraction is 0. It is attracted by Na plus on top and it is attracted by Na plus from the bottom. So again net attraction is 0. So Cl minus again does not have any particular orientation. So Na plus Cl minus, as a result, it is non-directional in nature. Now how do we represent this? Lewis representation. Of formation of ionic bonds. Now supposing I have sodium, I represent it like this with a dot, plus chlorine, it has 7 valence electrons, so I represent it like this, and this 1 electron of sodium will go to chlorine. So we have sodium gets a positive charge and chlorine, its octet is complete and it gets a negative charge. This is how we represent the formation of sodium chloride. Let's take another example. Magnesium oxide. Now magnesium has 2 electrons in its outermost shell and oxygen has 6 electrons in its outermost shell. Magnesium gives 2 electrons to oxygen. As a result, what happens? Magnesium gets a +2 positive charge and oxygen, its octet is complete and it gets a 2 minus charge. So this is how we show magnesium oxide. Last, let's show the formation of magnesium chloride. You have 2 electrons here of magnesium in the outermost shell, and you have 2 Cl over here, each with 7 electrons. Let me depict the 7 electrons, the second Cl, by blue dots so that it gets clearer. So magnesium gives 1 electron to one chlorine and 1 electron to the other chlorine. As a result, magnesium gets a positive charge, 2 positive charge, and chlorine over here, it acquires 8 electrons with a negative charge, and we will write like this. We can even write it like Mg2 plus twice this is it.